So I guess we'll officially get started and welcome everyone to the Scientist Speed session today. I'm Kristen Roberts. I'm the Public Affairs Director at the National MagLab, and I'm joined with my open house co-host.
That's right. I'm Carlos Arvilla from the Center of Integrating Research and Learning at the MagLab, and joining us both is Dr. Greg Boebinger.
The man of the hour.
Who's standing outside of the Magnet Lab as we speak.
At night.
So,
That's a cool trick. You have to show us how you turned it to night instantly.
He's magical, guys. So to get us started, Greg, today the format is anything goes, right? Whatever questions you've wondered about Greg, about the lab, about what it's like to run the lab, what it's like to be a physicist, his path to science, his favorite, what soda he poured into the cup that he's drinking out of right now. All things are on the table. This is sort of an ask me anything style session. So we are just here to kind of have fun and get to know Greg a little bit better. Just to get us started though, I think we should officially also congratulate Greg, Dr. Boebinger, on his recent inclusion in the National Academy of Sciences. Greg is a new National Academy member. So maybe you want to know, what that means, and who else is a National Academy member? Those questions can all be asked today too. We are here for all of it. So Greg, maybe to get us started, it would be nice to just, tell us a few minutes about yourself, the MagLab, kind of introduce the MagLab for everyone, and just a few minutes, 2, 3, 4 minutes.
Sure. So I grew up in Indiana and went to university there. But when I was a graduate student, so after I got my first degree, bachelor's degree from Purdue University, I went to MIT, and that's where the Magnet Lab was way back in the early 1980s when I was a graduate student. And I got so interested in doing research using high magnetic fields that I decided to start my own magnet lab when I went to Bell Labs, and I spent 11 years there. And then I joined, there had been a competition, and the National High Magnetic Field Laboratory, this group that consists of Florida State University, University of Florida, and Los Alamos National Lab, had won the competition, had beaten out MIT. And so I went to Los Alamos to run that branch of the Magnet Lab. And then starting on April Fool's Day of 2004, I became director of all of the Magnet Lab, which meant that I moved to Tallahassee and took this job where I have to wear a suit and tie every day, as you can see. And it's been a very exciting now 17 years. And I'd be happy to answer any questions that you may have.
I will start with the first question. Since we saw the Diet Coke and we know what you're drinking, say you were in the lab, what would you be snacking on? What's your go-to snack?
Believe it or not, I like beef jerky. And it's lots of protein, which is probably what I should be eating more of as opposed to the carbs. I'm not a small man.
Oh, but carbs are so delicious.
It's true. The virtual space doesn't give people the opportunity to see that Greg's like 6'4", 6.
Well, shame on you. I'm 6'5",
6'5",
and that's right. And I weigh more than 1/8 of a ton. I'll let you do the arithmetic. But both of my sons are bigger than I am. They're taller than I am.
So Greg, tell people a little bit, about the MagLab.
So the MagLab is an unusual laboratory because we exist so that we can build unique capabilities around high magnetic fields and then offer them up to visiting scientists. So most labs are collaborative, but each scientist kind of owns his or her own space, and they do in that space the research that they want to do. The Magnet Lab really is this wonderful mixture of our own scientists doing their own research, but then also welcoming scientists from all over the world. More than 170 universities around the United States have scientists who come to the Magnet Lab every year to do their experiments, and about 300 universities from around the world come to the Magnet Lab every year to do research because our magnets are so special, they're so different, and our people are so good at what they do.
All right.
Hey, I have a question that I know people will want to know. What like special access do you have as director of the lab, right? That everybody else doesn't have? Like what's special about directing the Mag Lab as opposed to, being one of those scientists that you just mentioned who can come and use it?
So to me, what's special about it is you get to develop the vision for the next 10 or 20 or 30 years. And you get to look for the best scientists and either attract them to do their experiments as a visitor or hire them at the Magnet Lab, and then give them the tools to do great research and get out of their way and watch what wonderful things they produce. So one of the things that I enjoy the most are watching our young men and women in the lab and seeing what they can come up with, what new science they can create from the tools that we've made available.
I'll go. Me and Chris just had that moment. Greg, what do you spend most of your day doing?
Let's see. I'd like to say thinking really hard, and but mostly it's talking and listening. So I don't spend as much time in the lab, but for me, that's okay. I've never been the kind of scientist who just lives to go into the lab. I've always liked it once we have data and there's data to talk about. And so it was an easy jump for me to go from being my own scientist, if you will, with my own students and postdoctoral researchers, and to then going into management where I have a team out in Los Alamos of about 30 scientists, or here about 300 scientists, where we're really talking about how do you get an organization that big coordinated? Where are the new opportunities? How in the heck are you going to find enough money to buy that expensive equipment? So most of my day is spent talking and listening, and I like it better if I can listen, because that means other people are coming up with the ideas.
So I have a question for you, Greg. You've been the director now for some time. How do you think magnet science has sort of changed, right? How do you think the lab has changed, the field has changed, and where do you think it's going, right? When you sort of project the next 20 years, right? When you are still leading the lab, or maybe have handed the reins to somebody else?
Yeah,
No.
yeah, I think that's more likely. So
what do you think that lab looks like?
So I started doing high magnetic field research in 1982. So I've seen 40 years, and it has been amazing to me how much high magnetic fields have advanced the frontiers in physics and in discovering new materials that go into new devices like this toy here, and in chemistry, in catalysts. If you don't know what a catalyst is, when chemical firms are manufacturing fertilizers or plastics, or any of the million modern materials that we build in factories, they need to have materials called catalysts that get that chemical reaction started. And we still don't fully understand catalysts, even though we use them to make billions of pounds of materials every year, to magnetic resonance imaging. The advances have been immense. So when I was at Bell Laboratories in the late 1980s, I was in the room when the first functional MRI was shown, the first data from a functional MRI. So MRI, for those of you who don't know, stands for magnetic resonance imaging. So magnetic means it uses magnets. Resonance, fancy word, we don't need to worry about it. Imaging means it takes a picture. So you put whichever part of the body you want to take a picture of inside a magnet. And oftentimes it's the whole body that goes sliding in. And you get a three-dimensional image of the structures in your body because of magnetic fields. Well, those really didn't exist very much when I was first starting out in research. And there was a revolution that was functional MRI. That's going one step further, and they will take pictures of your brain, but they will determine which parts of your brain are working on whatever problem you're thinking about. So they know which parts of the brain have to do with decision making and motor, meaning moving your body. And they've discovered that blind musicians use the part of the brain that the rest of us use to see. They use it when they're composing or playing music. So no part of the brain goes wasted. So can you imagine that for the last few decades, and in my research lifetime, we have been able to take images inside the body, but also to determine which parts of the brain are working on which problem. And so I was in the room when Professor Ogawa presented his first data. He will win the Nobel Prize someday, I predict. And it was just astonishing that we could tell when the rat was looking at a checkerboard pattern and when the rat wasn't. And from there, it's gone in incredible distances. And I think in the next 20 years, we will have taken over with a much improved way to detect cancer and to determine how to treat cancer by using advanced magnetic resonance imaging. That's one way I think that will have moved forward. I think we will be able to determine the structures of all the proteins in your body, not just the healthy ones, but the ones that are diseased. And we'll be able to take videos of how that protein was hijacked to then start to misbehave and become part of a disease. So the sky's the limit, frankly, in terms of what high magnetic fields can do.
And much more than just medical. MRI has been used in archaeology, paleontology, just countless fields of science. So
absolutely,
it is an amazing attribute that we've got. Okay, there's a question from our guests. They want to know how would you describe the role that math has played in your career?
So math is very important for science. It's the language of science. And just like if you want to describe what you're doing and you're an English major, you've got to use English. Or if you're a literature major, you use any language that you like. Of course, if you use a language that no one else speaks anymore, you may not be as successful. One of the many amazing things about scientists is that there's a universal language, and that's mathematics. And so if you're in school, you want to take as much math as you can, but you don't have to be the absolute best at math to be a scientist, and you don't have to love math to do science. So I'm good enough at math to do research, but I'm not as good as a lot of the scientists around me. So I've gone into what in physics is called experiment. So I do the experiments, or my students do the experiments, but very rarely do I sit down and write down the equations and then solve them. I know what my strengths are. Other than my good looks and my striking wardrobe, it's doing experiments in the laboratory and in brainstorming with theorists. I've been amazed how many times I'll be talking with the theorists who I consider to be the best in the world at what they do, and they do everything in calculations. They don't know their way around a laboratory. You don't want to let them in your laboratory because they'll break something. If they go, "What's that button?" You say, "Don't touch it." And I'll be talking to them and I'm brainstorming, but I'm using English because I'm not as good at math and I'm not as good as they are. And it seems to give them ideas on what calculation to go do. So the message is that you want to learn math, It's important to science. It's the language of science, but there's so many different things you can do in science that if you're not an expert at math, there's still room for you. Some of the most creative scientists out there don't do a lot of calculations, including a good number of people who've won the Nobel Prize. So stay with your strength is the message. Stay with what gets you really excited in your gut. If you like science, but after a while it starts to get just too detailed and it's getting into the little stuff, and you discover you like teaching other people about math or about science, then become a math or science teacher. We need plenty of those. And you can do it at whatever level you like. And so there's plenty of opportunities for a career in science.
So Greg, tell us, I know that you're, I know that you're kind of a Renaissance man, right? You happen to be a scientist, but you don't just have a degree in science, right? Tell us a little bit about all of that. You're also the person who will catch my editing mistakes. Greg's a wordsmith, a brilliant kind of person with words, as well as a scientist. So tell us a little bit about, I don't know how all those interests come together in you, but also like your path to science. I mean, you clearly have diverse interests. How did you end up in this high magnetic field universe?
It was not a straight path. Of all the awards I've won in my lifetime, maybe up until the National Academy of Sciences, the one that I'm most proud of, I won in high school. I won a writing award from the National Council of Teachers of English. And so to me, it meant I could write. And that's always been very important to me. When I went to an excellent high school, I had wonderful teachers. And then when I went to college, I started out as an electrical engineer, and I was less interested in the applications of science. And that's another thing. If you decide that the basic stuff isn't as interesting, but you really want to make applications, or you want to start a company and try to make some money, that's another thing you can do with a science degree. But getting back to my life, my dad was a minister. My mom taught elementary school. And so nobody could give me any advice on what career path to take, because I seemed to like engineering. But when I got into engineering, it was too applied. It was too much going to work for a company, which was not the thing that I wanted to do. But it's certainly a wonderful career path. And so after about a year, I decided I would. Well, maybe it was a few months. I decided I wanted to start taking philosophy classes. Because I'm really interested in the history of thought. It's amazing to me that 10,000 years ago, we were living in caves with a lot of know-how, the ability to live in the wild, and we've lost that knowledge now. So I mean no disrespect to our ancestors of 10,000 years ago, but none of the technologies that we have. Life has completely changed in the blink of an eye, at least in terms of geological terms. And I was interested in the history of thought, of human thought. And that's one thing you study with philosophy. And then I realized that wasn't a good career path for me. And I spent a summer job working out in Tucson, Arizona for IBM. And I discovered astronomy. And I learned that astronomy was now part of physics. And then I learned that the parts of engineering that I liked, the more basic, less applied parts, actually were physics. I didn't know that at the time. So I went back after my first 2 years of college, went back for the fall semester and told all my professors that I wanted to do physics. And of course, all my engineering professors said, this is a disaster, you're making a huge mistake. And all of the physics professors were saying, what can we do to help? And so they signed me up for physics classes, and I ended up getting 3 degrees in 4 years. And then I've really enjoyed traveling. To me, I don't like science fiction because I don't know what the rules are. People really can't fly. They really can't go backwards in time. There aren't such things as superheroes, but that's okay. If you want to believe in them, it's fine. I'm not gonna criticize that. But But if I go to a superhero movie, I don't care which one it is, I will fall asleep in the middle of it, or I'll get so fidgety that I just go out in the lobby and get some popcorn and I wait out the rest of the movie there. And believe me, I've done it. I don't even remember the titles of the movies anymore. So,
all right, so I'm not going to ask you your favorite Marvel superhero
I
or your
wouldn't
favorite
be
time
able to,
traveler. Okay.
I would not be able to tell you which ones were the Marvel versus the whichever the other ones. So I don't like science fiction, but what I do like are either going back in real history because life is different, or going to other countries because even in the day of the internet, life is different elsewhere, particularly if you get into the history of the place, which I do. So I like traveling. So I spent 1 year in England before then doing my PhD work at MIT. Then I went to Paris for a year to do research, and then I came back to the United States. I enjoy reading history, and it's almost other true stories. I tend to not like fiction as much, although I have read some fiction that I think is just wonderful.
So Greg, we have some, I know we have some graduate students joining us. And I just want to ask, if you could time travel and give yourself advice back in like the beginning of your graduate school period, what would you tell yourself?
That you should keep a positive spirit because things that are worth working for are worth working hard for. So I have always worked hard. It's something I learned from my parents. But I found that sometimes it would get me down. And I'd wonder if I could ever make it or not. And I can remember when my parents visited me and I was in the middle of my graduate work at MIT, and my dad said, "For the first time, I'm listening to you, and it sounds to me like you're not sure if you're going to succeed at this." And it was true. But it helped me when my son went through the same thing because I had been there. And sure enough, he's now pulled through and is doing very successfully. So it's easy to say after the fact, don't worry so much about it. But I guess that was what I was asked. That was what I was asked to give advice about. What would I say if I could go back? It would be that the hard work, you've got to do the hard work. It's hard to learn something, it's hard to think. There's a famous quote from Thomas Edison that it's amazing the lengths that people will go to avoid the hard work of thinking. But it pays off in the end. And to the extent that you can, take your breaks when you need to. When I was a graduate student, I only worked on the weekend if I absolutely had to get ready for an experiment on Monday. Otherwise, I took the weekends off. And I talked to some graduate students and they work nonstop. And I don't know how you do that. One of our leaders at the Magnet Lab just told me he hasn't taken a vacation since he arrived at the Magnet Lab 3 years ago. I don't know how you do that. I have to take a vacation or I go crazy. So, you can work hard, but my advice would also then, be to, take some time off and get away. If you can, go someplace off grid. The Galapagos has very bad cell phone coverage. And that's like time traveling, let me tell you, the Galapagos.
I love that.
Hey, Greg, what do you like on your pizza?
Pepperoni, sausage, and extra garlic.
Nice. I will have to try that.
I don't like anything green on my pizza. I don't like pineapple. That's an abomination. Onions are okay. Black olives are okay, but mostly just because they irritate my wife.
We'll edit that out of the final presentation.
Oh, okay, yeah. We'll edit that out in Remix. And I noticed she just printed something on the printer right next to me, so she may have overheard me.
So, Greg, with these, with all these things that you pursued before you landed in physics, if you were going to have, live a whole alternate life, what career what non-STEM career would you have picked?
I don't know that I would have been as good at it, but I think I would have enjoyed creative writing. I like writing fiction almost more than reading it, but I know that in order to become better at it, it might make sense to read more of it. But to me, Ernest Hemingway is an absolute genius with words. And I try, even though writing scientifically is very different than creative writing, I try to follow some of the rules he set for himself in terms of simple sentences and cutting down the wording and spending the time to find just the right word.
Yeah, there's a simplicity and an elegance to Ernest Hemingway's writing. Yeah, excellent. I do wonder, since we're talking about writing and books and reading, what are you reading right now?
I am reading Every Man a Hero, which is a memoir written by a man who is 98 years old, and he went in as a medic on the first wave on D-Day, and he sheltered wounded soldiers behind a slab of concrete that was already on the beach. It wasn't part of the defense works or anything, and that slab is named after him. There's a plaque on that slab. If you go to Omaha Beach, you can see it. So it's gotten rave reviews. He was interviewed on 60 Minutes, I think it was recently. It's gotten rave reviews because it's like sitting down at your grandfather's knee and listening to stories. And I very much like first-person accounts. Journals, and there's one known journal from a foot soldier in Napoleon's army when he invaded Russia to try to capture Moscow. It's an incredible story of just how you survive in such difficult circumstances. And so that's kind of my escapism, is to try to they're not all dangerous situations. They're not all war journals. But just what was life like? There's testimonials from the Middle Ages that I love to read, because life was so much different then than it is now.
So, Greg, is there a book or perhaps a movie that makes you cry that you're willing to admit to?
Well, I'm certainly willing to admit I cry. There's many people who've seen me do it.
Or a piece of music. I know you listen to a lot of beautiful music.
Piece of music, no question. Shostakovich's Fifth Symphony is absolutely sublime. I'll tell you the story in just a minute. I can tell you the story in an hour, but I'll give you the short version. When he was young and growing up under Stalin, he was seen as a modern-day Mozart. And Stalin wanted to use his skills to further glorify the Soviet state. And he just would not allow that to happen. And I'm a firm believer that limitations help to promote creativity. And so not being perfect and not being the best is nothing to cry about. It will drive you in creative directions other than the one that other people take, because you're dealing with your own limitations. So his limitation was he had to deal with Stalin. Well, he had written an opera, and it was denounced by Stalin in Pravda, in the official newspaper, and so his life was at risk. He had a packed suitcase and slept outside the door of his apartment because he was afraid that he would be collected in the middle of the night, and he was hoping they would leave his family unharmed. He did not release his Fourth Symphony because he probably would have then been executed because it was too experimental. And so he had to write his Fifth Symphony so that it met his artistic standards, but would satisfy the Soviet officials. And he wrote an absolutely stunning piece of art where everything starts to build excitement, but then it kind of fades. And it ends with 242 A notes played by the violins. And it starts to sound heroic after a while. But then after a while, you're wondering, is something stuck here? What's going on? And something's not right. And he managed to get to write one of the finest symphonies ever written, and dodge Stalin's executioners. It's an amazing story. And I almost always am in tears when I hear it.
Great story. Thank you. I saw another question come in. A hot topic during open house was, is cereal a soup?
No, there's no question, Carrie. Get off it.
I didn't say that.
I love it. I love this. I love the certainty of the physicists. I just want to say this. I love the certainty of the physicists. When we did this question during house, a lot of our other scientists were very thoughtful about it.
Oh no, there's no question. And Carrie actually agrees with me. I apologize, Carrie. I didn't realize that that you were on the right team here. So and I'm not surprised, because usually Carrie and I agree. If I find that Carrie agrees with me, I'm that much more confident.
Well, the follow-up question.
Ryan Bomback was just as certain as you were, Greg. So I think there's something to say about the physicists and their certainty of their answers. Some of our other chemists and paleoceanographers were very like, wait a minute, I don't know.
So is a hot dog a sandwich?
Maybe
that's the logical follow-up.
Maybe that tells you how different mental abilities drive you into different sciences. I don't know. Maybe maybe physicists would be terrible paleontologists because we're just too snap answers. I don't know.
Yeah. The follow-up. Go ahead, Carlos.
It does a hot dog count as a sandwich then?
A hot dog as a sandwich?
Or is it more of a turnover? Is it a wrap?
I think that's an issue that doesn't rise to the level of being an important question for such a distinguished crowd as we have here today.
So we do have a question in the chat that I will ask about whether you share the same passion with movies, the way that you do for kind of books and songs. And do you have favorite movie directors, or is there a favorite movie on your list?
So I'm having trouble coming up with movie directors' names. I've enjoyed a lot of the young directors' output in the last couple of years, but I'm drawing a blank right now. When I was growing up, I was a huge fan of Woody Allen's more serious movies, and I still think they've borne the test of time. I know he's become a controversial figure, but Annie Hall to me is just a wonderful film that sort of points to how complicated and confusing life is at one level, but how simple it is when it comes down to just building and maintaining friendships. My favorite bird is probably one of the moths. So this is a tropical bird. I'm a bird watcher. I saw a question in the column. I like watching birds, and I'm up to about 1,000 species that I've identified in my life. Not the first, of course. I went to the books to find out. But moths are an interesting bird because they're typically brightly colored, and they have 2 long tail feathers that then have an extra tuft at the end. So you have feather, and then just the bare spine, and then a little bit more feather at the end. And they can be really long tail feathers. But I'm a huge fan of around here. My favorite is the swallow-tailed kite, the almost all white bird with some black trim that has a deeply forked tail. And if you ever see the Florida birding trail signs, it's the bird that's on the Florida birding trail signs. And I saw 2 of them just last week. They usually don't come this far north in Florida.
So Greg,
That,
speaking of birds, if you had a pet parrot, what would you teach it to say?
Inadvertently or advertently, as they say.
Wait, well, as you consider that, I have to throw in that the state bird of Nicaragua, where I was born, is a mutmut, which I did not know because I only know it by its Spanish name, garavarancha, but it is the turquoise-browed mutmut.
Aha.
You know what bird that is?
Well, I know we saw one in Peru that has almost a luminescent blue halo. But I think that's the blue cat, but it might be the same one. Yeah, we could stop this meeting now and both Google it and see what we come up with. But
we got to hear about the parrot.
Let's stay with the parrot. I think I would try to teach it something that would be a joke for when a visitor came into the house. So something like, "What are you doing here?" Something along those lines would be what I would go for. Or, "Can't you leave us alone?" Or, "Shh, keep it down." Yeah, something like that.
That says a lot about Greg. I think values a sense of humor almost above all else.
Indeed. It is a fact that when I give a science talk, and it's one of the reasons whereas I give anywhere from 10 to 20 talks a year on science, on the MagLab, on my own research. During the era of Zoom, I've only given one. I gave a talk at Stanford. It was actually a talk to Stanford because it was by Zoom. And I hate Zoom because I can't tell if the audience is laughing. And to me, the talk is not successful if I don't get my main science points across, get some questions on important issues, so I know that at least some folks feel that there was real content there, but above all, get some laughs. I have to make people laugh. It's weird because I'm also somewhat shy. Just before the talk, I don't want to give the talk. But as soon as I get the first laugh, the show is on. And I just love it. So I had one opportunity to MC the celebration for David Pines's, I think it would have been his 80th birthday, but it might have been his 70th. The thing I like most about it is that I could make jokes at the expense of some of the most brilliant physicists in the world, because David Pines was one of the most brilliant physicists in the world. So he attracted the top-notch physicists to his birthday celebration. I was the MC, so I could make jokes. I couldn't outthink them, but I could go faster than they could in terms of saying humorous things. Let's see. Do I have a magic?
Yeah, there's
test? Yeah.
First of all, Greg, you might have to explain this question to us. There's a question in the chat about whether you have a magic Tesla value, like 3.14 Tesla or something. So I don't know what a magic Tesla value means. Maybe that's an insider science thing that you can tell the rest of us about.
I don't think so. I think it's just saying, is there a special number? For me, it's 72.
Like a favorite.
Yeah, for me, it's 72. And the reason is I went to Bell Labs and I wanted to build my own pulsed magnet lab. And so I had to start with just one technician. And the two of us built up the energy, the power supply system. We designed the magnets, we built the magnets. And at the time, the world record was in, I think, the mid 60s, but nobody was taking any data above 50 Tesla. That was the highest in the world. And incidentally, now it's 100 Tesla. But here, the two of us we're launching off. It was the first major thing I did in my career when I was in charge of my own research direction. And we, in a matter of a couple of years, built magnets that broke the world record and went to 72 Tesla without destroying themselves. Also important for science, we could pulse them 3 times a minute, or sorry, 3 times an hour. There's a difference there. 3 times an hour when other competing technologies had to wait an hour or 2. So we could get 3 times as much data. And then we started writing papers and publishing data. But 72, it was a result that I could take not only to my supervisors and bosses at Bell Labs, but to my former professors at MIT. And we set the record right before the biggest meeting of the year, the March meeting. And I can remember on the escalator, I was going down and one of the people who served on my thesis committee was going up. And I turned around and shouted to Mark Kastner that I'd gotten to 72 Tesla. And he was very proud of me. And you never lose respect for people who you've respected early in your life. Or at least if you have a lucky life, those people never fail you. And Mark Kastner is one of the many physics professors who I still hold in very high regard. And so his affirmation that we'd really done something at 72 Tesla really meant a lot to me. I don't know if Mark's tuned in here today, but if he is, I'll break out crying for you.
Oh, if you're here, let us know in the chat. These are such great questions. I just want to tell you all, we probably only have Greg for another 5 to 10 minutes or so. So if there's a question you are really wondering, go ahead and add it into the chat now. I have a few more fun questions just to kind of keep it light and fun. Greg, if you had a boat, what would you name your boat?
The Unsinkable 2.
Bold.
Wait, 2 as in the number 2 or 2 as
The
in
number
also?
2, the Roman numeral 2. So that people ask, whatever happened to the Unsinkable 1?
Love it. Love it. I like the certainty. I like the speed. I love it.
Oddly enough, that was not a planted question. I've had that answer in my head for decades, that if I ever buy a boat, that's what I'm going to call it.
And it all culminated to right now. What a beautiful story.
What a beautiful story. I'm getting misty.
I'm so glad we could have that moment all together. Greg, do you have a skill that people would be surprised that you have? Like, do you I don't know, can you whittle a rocking chair or some beautiful piece of art, or are you a great painter, or I don't know, just a surprising skill that people might not expect?
Well, I'm a huge collector of things. So I collect coins, I collect shells. Our coffee table has a glass top because in it we have baleen from a whale and teeth from a cave bear and fossilized dinosaur bones. And so I really like collecting things. The other thing that many people may not know about me, but I think, and I don't mean for this to sound really serious, but I'm one of the many people out there who's bipolar. And your own mental state or mental condition is one of those things that doesn't have to get in the way of a career in science. And in some ways, it helps me be more creative. You just have to learn how to cope, and you have to learn how to take care of yourself. And maybe that's why I took weekends off, even though at the time I didn't know I was bipolar. I knew that my brain needed a rest, because when I get tired, it really spins out of control. So, if there's anything that you think is a weakness or anything that you're worried might be holding you back, you're probably not correct about that. If you feel that you are, work on making it better, get advice on how to do better. But a lot of things that people think are weaknesses are really just differences. And that's the reason that having diversity in science is so critically important, because even though there's right answers in science, and the mathematics is the language. It's still a creative endeavor of humanity. And creativity comes in all shapes and sizes. And we need more diversity in science than we have now. And so that might be my final big message, is that we're celebrating the increasing diversity in science. We're working hard to further advance it. We don't always know how to do that, but we're definitely on the team that's trying to build that diversity in the coming years.
I can't think of a more important place to end our conversation. Carlos, can you? It's a pretty powerful closing from MagLab Director, new National Academy member, Greg Boebinger. We appreciate you spending time with us today to talk to Greg. And of course, on behalf of all the participants at this moment and all the people who might be watching this later on YouTube, thank you to Dr. Boebinger for his time and honesty and willingness to have fun with us today. But also, I don't know, I feel very inspired by this closing message.
Well, good.
Inclusion is always a good message.
Yeah.
It's been fun.
All right, and everybody stay tuned. For the MagLab's channels and social media accounts, we'll do more of these scientist speed sessions. If there's someone you'd like to talk to be featured, let us know. Just post it on our Facebook wall, tweet us, and we will try to highlight that person. So thank you all. We look forward to talking to you more in the years and months and minutes to come.
Goodbye, everyone.
Bye, everybody.